we did promise it last informal, and the idea is to just run through lots and lots and lots of little basics about telescopes and what to do with them, hoping that it'll cause a few questions and answers and comments at the end. So I do apologize to all the experts who are with us tonight. You might find it a bit boring, but you might still have some comments you might like to add that I've maybe missed out at the end. So I'll ask that you mute yourselves just whilst I talk, and then we'll have a good time unmuted later on. So if I can just share the PowerPoint. I don't know what you can see. Can you see the slideshow?
Yeah, that's coming through fine, Rod.
Okay. Lovely. So if you are having problems with your telescopes and setting them up, do not worry, you're in good company. There is an American organization doing just the same as you right at this very minute as we speak. I thought this was an excellent innovation, that they can put a lens on one of their cameras on the James Webb and actually get a view of the mirror itself. I thought that was fantastic. But that's what they've managed. Right, can you see a small telescope?
Yeah.
Yes? Okay. So let's just very quickly run through lots and lots of different types and bits and things. This tripod looks a bit like a photographic tripod, which is fair enough. A photographic tripod, if you can get a telescope to attach, is very nice. Its one big drawback is that you cannot finely move it. The heavens has a nasty habit of processing along as the night goes by, and you've got to somehow follow it. And it could be that also if the thing is not perfectly balanced, the telescope is quite difficult actually to keep in one place if you just simply have a clutch that you are tightening and releasing and moving by hand. It's quite a difficult thing to do. So although a photographic tripod is nice, it's not really the answer to anything. Here's another tripod which can move up and down and left to right. For that reason, it's called altazimuth. And this time I can see a little stop that you on the right hand side there that you can grip and then loosen, and that will help, and it'll leave the other axis free. That's not the perfect answer to everything either, but it's a little bit of an improvement that you've been able to lock one axis. Okay, and it's the axis, by the way, that would show itself by imbalance. So if, for instance, the eyepiece was too heavy, the telescope would want to fall down and the front of the telescope rise up. So at least that bar will prevent that. So the next improvement would be to have an up and down and left to right, but this time you've got some fine controls on it, and that's a tremendous improvement. Now you can hold each handle with two hands, the two things that are dropping down, and you can follow a star, or you can accurately point to a star without having to undo clutches and then retighten them later on, and having to do that every half minute. So slow motions are great. They work little worm screws which turn the telescope either up or down or left to right very, very finely. What sort of telescope? You've just seen a variety of refractors. Refractors have lenses at the front and an eyepiece at the back. This one's got nothing at the front. It's got a mirror at the back doing the same job as a lens, and then it's got a little diagonal mirror near the front, which will direct the light into your eyepiece so that your head does not block the view. Another sort of alt-azimuth mount, especially for a reflector, is the Dobsonian, where you still got an up and down in the left to right, but Dobsonians are particularly good at mounting very large telescopes. But just a minute, just think what would happen if that was a refractor on the end. You'd have to be lying down with your head on the ground, trying to see into the back of it. So personally, I think there's a big advantage of having an arrangement that has an eyepiece near the front of the telescope. Up and down and left to right is all very well, but I'm afraid the universe doesn't agree with it because it's got a nasty tilt. And the spin of the Earth shown in that on that blue arrow, which will happen every day, is tilted. The axis of spin is tilted. So we do have a problem with a simple up and down and left to right. It means that every time the star moves, you're going to have to alter both axes as you go. So we're exceedingly lucky in the Northern Hemisphere because we just so happen to have a little blob in the middle of the apparent rotation of the stars called Polaris. Polaris is a blob that's nearly exactly on the North Celestial Pole. The Australians don't have such luxury, but we do. So it's a nice thing that we've got something to aim for. And I think I've got the right way of rotation as well. That's the way it goes. So we have our back to south at the moment. We're looking north. So I think the next improvement will be to have an axis like what you've seen, but let's tilt it. So instead of up and down and left to right, we'll have a tilted one that points to the North Celestial Pole, about which all the stars appear to rotate. And our lucky star is Polaris. So if we could aim it at that, and we can set our telescope to follow or to point to a star, all we have to do now is lock one axis called the declination axis and just slowly move with those slow motions. I can see those two handles again. Slowly move the right ascension axis. And so you only need now to move one axis in order to keep up with your moving star. The right ascension axis is the lower one, the one that you see with the handle nearest to you in blue. An even better improvement is to have a little blue box, which is what this mount has, still pointing to the North Pole, but the little blue box has a motor in it. So let's take away those slow motion handles and replace it with something you can just switch on and off. And as an added benefit, you can get the motor to speed up and sort of slew over to a star first, before you then switch it onto normal sky tracking, 1 revolution per 24 hours. I'll just point out as well before we leave this picture that on the left and right of the blue box, you see a black cap, which is pointing to Polaris, and what looks to be a blue back end as well. Just bear that in mind for later on. So if you have an equatorial mount, as it's called, because it's pointing to the sort of celestial equator and pole, in our country, we need it just a bit over 53 degrees, which is quite high actually. And sure enough, when you look at Polaris, you do get an achy neck after a while. So you're going to have to adjust your mount, which you can do with the little screw that you might see on the bottom right with a little blue arrow pointing at it. And you can adjust it so that something somewhere on its horizontal axis will say 53 and a bit degrees. And then you know that you're more or less right. It almost doesn't matter because you're probably not going to put it on level ground anyhow. The ground can be a few degrees out. And so you might find yourself doing a fine adjustment if you want to, by extending or contracting the tripod legs might be just as effective, as because altering that screw is actually quite difficult. I'm only showing one screw there. On a lot of mounts, it's two screws. There's one as arrowed in blue, but there's one on the other side to stop it as well from over rotating. Another thing you're going to have to do is you're going to have to balance the telescope, because you don't want it weighted over to one side. It will be very difficult to point. So you can swing it so the arm is horizontal and sort of slide the balancing weights so that you don't, the telescope doesn't want to go one way or the other. And in a similar way, the telescope itself, I'm just wondering if it's being gripped by the mount in the right place. So you might have to go forward and backwards in the direction of those angled green arrows near the top of the picture, and so that it's not overbalanced in that way either. So hopefully everything is nice and perfectly balanced. Now, going back to the the mount that I showed you a few slides ago, there was a blue cap and something on its back side. Well, that is housing a polar scope if it's an equatorial mount, and it's a little aid to help you to find just exactly where the North Pole is. Now, quite honestly, if you're just doing visual astronomy, you might not need all this. All you'll need is 53 and a bit degrees. That's nice. You can see the scale on the bottom left of that picture. So you could just rely on it being 53 degrees high, and then you just loosely, by eye, line up the telescope in the direction of north. And then hopefully it'll be somewhere near Polaris. And for visual things, it doesn't really matter that you're a little bit out. It's okay. You can always correct it with your slow motions or your motor drive. But the thing that we're looking at now is a polar scope, and you can do it a lot more accurately. Now, I've been telling you a little bit of a lie when I said we just so happen to have a pole star just at the North Celestial Pole. In fact, it's not quite there. Excuse me. So when you align your telescope and you're looking through your polar scope, you don't really want to put Polaris in the center. What you really need to do is put it to one side at a distance roughly equal to the diameter of that little circle that you will see that's stamped onto your polar scope image. And one way of doing that is to look at the little bear, and the yellow star called Kobach, I don't know how you pronounce it, shows you the direction in which to push Polaris off a bit if you want the real exact North Celestial Pole. So what you want to do is push the telescope. In this case, if it looked like this at this particular season, you want to push Polaris a little over to the left so that the star will appear at an angle, the same angle. By the way, I've tried to make these two angles roughly the same. And you can tell where that angle is by looking at that Kobach star. It's one of the brighter stars in the Little Bear. There are not many bright stars in the Little Bear, but it does show you roughly the direction to tilt your telescope over to if you want the North Celestial Pole. Okay, and if you're not sure because you're looking at through a little mini telescope and looking through the polar scope, what you might like to do is look through it and then give your telescope a nudge and see how it reacts on what you see through the polar scope, and then you'll know what to adjust the Polaris star to, which bit of that circle that you ought to put it on. Okay, so you can sort of spend hours of fun doing that, and you'll get up and have a stiff neck unless you put a little right angle viewer on the end of that little polar scope finder. So I improvised one just using a little prism. And if anyone has any good old-fashioned 1-inch eyepiece accessories, you might have a 1-inch diagonal, and you'll find that will fit over that polar scope eyepiece rather well. And then you can look down on it instead of having to crouch down on the ground and break your neck. Right, what else do we have to do before we start using the telescope? Well, I think golden rule number 1 is use a low power, because you don't need anything more either for lining up for instance, the finder that you see at the top there to the telescope proper. And also, if you're looking for an object, then you've got a much better chance of finding it when you start off with a low power. I'll talk about eyepieces later. Your first job before you even try and look at an object is to do that job of lining up the finder with the telescope proper. So you don't have to wait till night time to do that. If, for instance, this is your neighbour's house, you can just find a seagull on the top or something like that, and just make sure that exactly the right place is seen in both the finder scope and the telescope. It might be that you have a red dot finder, and the same applies. Unfortunately, it means you don't get any magnification. So anything you can't see with your normal eye in the night sky, you won't be able to see it through this either. But there's 2 adjustments. One is a screw going up and down that says altitude. The other is a screw that goes left to right and it says azimuth. Okay. By the way, something I do just about every other time that I use a red dot finder is forget to switch it off. So make sure you switch the red dot off, because there's a little battery inside, or a set of little watch batteries or something, flat batteries. And more than once I've come to it, wanted it to work, and found that I've got a flat battery because it's been on for the last 2 months without me knowing. That's what a red dot finder looks like. It just looks like a red dot as seen on the top left. If you've got a posh one, it might be a circle. You can even get them so that they flash. My advice is don't have it on too bright, because it'll blind everything else that you're trying to look at. So have it just bright enough to see. There you can see Orion, and that really is how it looks, because there's no magnification at all. It's just ordinary eye's view. You might be saying to yourself, okay, what magnification should I use? Well, these are all the implications for highs and lows of magnification when you swap eyepieces. So obviously, a low magnification will give a smaller image. So you might not have realized it, although it's smaller, it'll be brighter. And that sometimes is a big advantage on it being big. The outline, the definition will also be sharper because the telescope is having an easier job of getting an exact focus. At low magnification, I don't know why I've said more movement. It should have been the other way around. Sorry about that. At low magnification, there is less movement. You can cross that out if you want. Less movement, either from the wind or from you nudging the telescope or from the star's own motion across the sky. It'll be less. At high magnification, it'll be greater, because not only is the image magnified, but its movement is magnified as well. So it's altogether a more difficult thing to achieve as a high magnification image, especially if you're desperately trying to keep it in the center of the field of view. Low magnifications might, if they're very low, have a narrower apparent field of view. You might find if you put a 30mm eyepiece up to your eye, you can even buy a 40mm eyepiece and compare it with, say, a 10mm, you'll probably find that you're looking at a smaller disc. If you've got glasses, you might have better eye relief. You don't have to stick your eye right up and into the eyepiece, as you might do with a higher magnification eyepiece. And as I've said before, when you're starting out to find an object or to line up the telescope, a low magnification is a lot easier to aim. So how does a telescope work? Basically, you've got the thing at the front called an objective that produces an image. When the light is coming from infinity, it'll be at the focal point, which is somewhere near to the thing on the right, which is the eyepiece. So you get an image, and then the eyepiece does the job of magnifying it like a magnifying glass. So putting an eyepiece up into a telescope is just like putting a magnifying glass to your eye and looking at a fly's wing. It's doing exactly the same thing. It's just magnifying whatever you've produced just inside the telescope there. So that's all there is to it. You'll notice that the light rays are coming in more or less parallel from the left-hand side of the telescope, and they're going out more or less parallel as well. So your eye is sort of relaxed and thinks that it's looking to infinity. So if you do have glasses for distances, keep them on. Also, glasses for distances will help with any astigmatism that you've got as well. It'll kill that. So I said I'd come back to eyepieces. How do you measure magnification? Well, it depends on how long your telescope is, and therefore what the objective focal length of the telescope is, and that should be very long. It's another way of saying that the front lens on the left should be very weak. And it depends on the focal length of the eyepiece. The eyepiece should be short, so it's like a strong magnifying glass. Stronger the glass, the more magnification you get. Typical focal length of a telescope might be 1 meter. A typical focal length of an eyepiece might be 10mm. So you divide one by the other and you get 100. So you're looking at 100. So if you want to reduce that, you take the eyepiece out and you replace it with a slightly weaker eyepiece with a longer focal length. And I've written down that a powerful inverted commas eyepiece has a short focal length, but watch it, it'll have all those attached problems. And a powerful telescope has a long focal length objective. That's why most telescopes are sort of long, thin things. You might remember the good old-fashioned Victorian ones, which seemed to, and before, which seemed to go off forever. Great big things that they had, you know, on the sides of houses and things. If you don't like telescopes with lenses, refractors, you might like to use a mirror instead, and it's doing exactly the same job, a concave mirror, as what a convex objective did. The only thing is you've got to push the light rays off to one side so that your head is not in the way of the view, so you need a little flat as well. You could argue that that's a problem because your quality of your optics now depends on a second surface as well as the objective. Usually people don't talk about flat mirrors, do they? They talk about the the accuracy of the figuring of the objective, but they don't seem to mention the accuracy of the figuring of the little flat mirror. We hope that they're the same quality. You could have a catadioptric telescope, and that has a similar idea, but instead of a 45, you have a little convex mirror instead, and you drill a hole in the middle of your primary mirror at the right-hand side, so you stick your eyepiece behind the telescope, so it starts to look a little bit like a refractor. One nice thing about that is that you can get very large apparent focal lengths of primaries in a comparatively short physical space. The curve of the secondary helps in that as well. I've got a telephoto lens, which is a mirror lens, 500 millimeters. And although it's 500 millimeters, physically it's only about 4 inches long. That sounds like the ultimate telescope, and a lot of people do use them, but it's okay until you want to have a low magnification view, and then you've got a problem. It'll have problems producing something at a low magnification. An even better version is to try and correct some of the aberrations, some of the problems with the light of reflecting on mirror surfaces, and you can do that with something called a correcting lens at the front. Trouble with the correcting lens is that it makes it look a bit like a refractor now, and it might be subject to the dewing up problem that some people have mentioned recently. Okay, so what are you going to buy next? Is it going to be a refractor, or is it going to be a Newtonian reflector? I've put catadioptric reflectors in with refractors because they do produce similar characteristics, I think. If you want, like me, if you don't want to spend a lot of money, but you do want the biggest telescope as possible, you'll buy the reflector because it does work out cheaper. Chromatic aberration is something that only happens with lenses, so we'll all get it to some degree with the eyepiece, but you won't get it with the mirror of a reflector. A lower eyepiece is important if you don't want to give yourself a backache. It'd be nice to have an eyepiece, as I mentioned earlier on, which is higher up for you to comfortably stand up and look through. And it's also nice to be able to look at something that's horizontal, which, for instance, you would get with a Dobsonian mount. So a refractor does need a much higher tripod. Lateral inversion is something that was mentioned recently in emails talking about the moon. You'll only get that with a Newtonian because of the little secondary mirror, which is bouncing the light off to one side. A lighter telescope, physically, a lightweight telescope would, per unit size of objective, would be the reflector. It can be made lighter. A refractor needs a diagonal. A reflector needs collimating. That is, the mirrors must be lined up fairly frequently, especially if you're transporting them in the car. I'm not saying a refractor doesn't need it, or a catadioptic, but it seems to be able to keep its collimation, its lining up a lot better. Something else that people have been talking about recently is the ease of getting dewed up in cold nights, especially I've found when you're on a new in field. You seem to get a lot of moisture coming over from the grass. So anything with a surface that's right near the end, you're going to have to build that tube up a bit with a little foam extension. Even 6 inches is better than nothing, just to try and divert some of the damp air from sweeping past your front lens, or catadioptric correcting lens. A Newtonian will be much more proof to it than that, because the main mirror is right at the bottom. Yes, there is a secondary near the end, but it's only near the end, it's not at the end, and also it's pointing downwards, so that's a help as well to stop it getting dewed up. It does happen, but not as much. And if you want low magnifications, for instance, for astrophotography, then you might like a lower focal ratio, which Newtonian reflectors are best at doing. They can give you something shorter and a weaker power. If you want to go to the next stage up, instead of spending all night trying to find M101, which I defy anyone to, by the way, by eye, you might like to get something electronic, something that not just follows the night sky once you've pointed it, but it'll actually find the objects itself. So it's a little computer hidden away in that base, and you just tell it where to go, and it'll go there once you've lined it up, once you've told it a few things about where the sky is. So that takes all the fun out of it, but we all have one. That's another version, that's another altazimuth version of the same thing. And there's another altazimuth version of the same thing. And there's an equatorial version of the same thing. So they will enable you to go to the object that you've got. That's a nice picture, that, because can you see the 2 thumb screws? I don't know if you can see my mouse cursor, but there's one on the left and one on the right of the altitude dial, and that's to lock the telescope at 53 and a bit degrees. Okay, if you're into astrophotography, I do recommend an equatorial version rather than an altazimuth version, because if you have a very long time exposure, like a minute, you might find that the stars on the outside have rotated. In fact, everything will have rotated, but you'll see it most in the objects to the edges of the field of view, and you will not be able to stop it unless you have some sort of clever rotating camera device. That will not produce an apparent rotation. That will be faithful to what it sees, and it'll stay locked onto the right orientation. Another thing you might like to contemplate is filters. The before and after, before is spelt wrong, must be American, I think that's a bit too good to be true, quite honestly. but different filters can be bought for different effects. So there's a deep sky hydrogen cloud filter that's getting the benefit from a hydrogen filter. And on the bottom is putting in a coloured filter, for instance, an orange one to show up the contrasts of the dark areas on Mars. And I'm sure you can agree that the left-hand image is giving you more definition than the right-hand. So it's the same telescope, same everything, same exposures, same camera, but it's just got a different filter in the way. Different planets and the moon vary, benefit, sorry, from different filters, and that's your lot. So that's taken rather a long time, but I'll stop now, and I just invite people to ask any questions that they might have, and perhaps if I shut up and ask other people to answer them if they've got the answer.
A good point. I mean, a lot of good points there, Rod, but one thing in particular which always annoyed me in the laboratory with students using optical instruments, that they will not allow their eyes to focus in infinity. So when they look with a spectroscope or a microscope or something, their eyes are actually trying to look at the eyepiece of what they're using, and you end up with eye strain. And if you're going to spend a lot of time looking through the telescope, for goodness sake, try and let your eyes relax as though you are just looking at something in infinity. It's not an easy trick, and it needs a bit of practice. But one way to do it is to keep both eyes open. And so one eye will be looking at the night sky, and the other eye will be looking through the telescope. Again, a difficult trick to bring about, but it does save an awful lot of eye strain.
One of the things, oh, sorry, David, sorry.
Oh, you go first, David.
Sure. Mine's more a comment, but I know it's a very simple one, but as people know, I'm a complete novice on telescopes, so I know BA bugger all about them. But one thing I was going to say was, it's just really a comment. If you want to say something about it, is, you know, when I've had my primitive telescope out and I've been looking at the moon, and then I've come into, you know, to get a drink, and when I've gone out, I thought, where the hell's the moon gone? And I couldn't believe how fast things are moving across the sky, because when you're doing naked eye observing, you're not really noticing it unless you specifically look for it. So if you got an hour later, you'd notice obviously things have moved. But I'm thinking with a telescope, you sort of, if you don't watch out, you know, and you've got one like mine, which is just manually set up, and then within a few seconds you've got to reset it because it's moved the image.
Well, my solution is use, as I've said in the little talk, use a lower magnification, and that'll slow it down. And if it's the moon you're looking at, a moon filter is absolutely essential. Something you can screw into your eyepiece, because the moon is far, far too bright.
Yeah.
So if you spend half an hour looking at the moon, it's like looking at a you know, a lamp bulb.
60-watt bulb, yeah.
I was going to say, I've got two eyepieces which I can thank Robin Jakewitz. They came from you originally, my two eyepieces. You probably don't remember, but you said I could keep them. I've had them.
Yeah, I remember that, yes.
Yeah, yeah, thanks very much. Thank you. Thanks, Rob. Thank you.
Yes, David.
Yeah, Rod, that was really nicely put together, I thought, that talk. I wonder if you could just say a little bit more about what exactly is the correcting lens in a catadioptric telescope correcting for? What contribution is it making exactly?
Not too sure, apart from any inaccuracy in the parabolic nature of the primary. I would guess that most of the aberration is going to come from the secondary, that curved secondary. So it might be correcting for that. I do know the shape of it. It starts off being concave around the edges, and as you get nearer to the middle, believe it or not, it goes convex.
In the original Schmidt telescope, which is where these catadioptric things are based on, the primary was spherical. So the corrector plate was designed to make it look like a parabola.
All right.
It's much easier and cheaper to make spherical mirrors than it is to make parabolic mirrors, but then the corrector plate's probably difficult. But it is the aberrations in the various bits of optics, and it just corrects for that.
Right, thanks.
Also keeps the muck out of your telescope, which is quite useful.
Yeah.
Can I mention something else? Sorry, I'm showing my ignorance again, but you mentioned, and I'm already aware of this, that Polaris is about a degree or whatever away from the North Celestial Pole. Can I ask a really simple question? Is the North Celestial Pole then to the right of Polaris or to the left of Polaris?
Depends what time of day it is.
Right.
What time of day and what season?
I'm thinking mostly sort of like early evening.
Depends on the season. Just keep a lookout for the little bear, because the celestial pole is just pushed off a little way towards the end of the little bear that Polaris is at the end of.
Right. Thanks. Did you happen to know, just by any chance, the star which is equivalent in the to the South Celestial Pole? I think it's called Sigma Octantis, whatever. Is that the same number of degrees away from the South Celestial Pole, or the same, exactly the same?
I wasn't aware that there was any reasonable star anywhere near the South Celestial Pole.
That's the one that's given in the Astronomical Dictionary, Phillips one.
There's one very close, but it's much fainter than
Fainter,
yeah. That's the one that's given, Sigma Octantis, in the constellation Octans. And
You've usually got to use the Southern Cross.
Yeah.
That points to it. It's if you're just doing it visually.
Right.
Does anyone have any, sort of particularly annoying problems with their telescopes or mounts, or unable to set them up, especially if it's equatorial? It's a mystery to me why the standard amateur equatorial uses counterweights. I don't know why everyone's gone for German equatorials. There are equatorials that just look like a big Y shape, a big fork, and they have a bit like a tilted over Dobsonian. And if you go into a lot of big observatories, that's what they have. Why you can't produce a small one, I don't know. I'm sure it'd be a lot lighter, easier to transport. But anyhow, that's just me. I hate counterweights. I think they're a complete waste of weight.
The catadioptrics are like that, aren't they? They don't have a counterweight. They just have either a single arm or two arms with a telescope in between, and then it just points. But I think for a refractor, it's not quite so easy. In the earlier refractors, it's much easier to have a German equatorial, because then you could swing it to anywhere in the sky. Whereas if it was between forks, you'd be very limited when the telescope eventually hit the bottom of the fork. But they are a nuisance, I agree.
For polar alignment, I've often used a polar alignment app on my mobile phone, but I must admit I always end up being confused whether it's showing me, it shows the orientation, exactly where the pole star should be relative to the North Celestial Pole. I always end up being confused whether it's showing me the image that you should get in the polar alignment telescope or the orientation you would see with the naked eye. Is it usually the telescopic view that such apps show? Do you use one?
It is on the app I use.
Pardon, Steve?
As I said, it is on the app I use. It's the telescope view or the periscope view.
Can I just say, because what you said, Robin, you said depends on the season, the position of the Polaris you know, vis-a-vis the North Celestial Pole. Because I was given to understand that Polaris was in a fixed position. I didn't realise it varied the position.
No, it just goes around the celestial pole.
Ah, right. Thank you. Thank you. Thank you.
Any more points? Is there anything I've missed out?
No, the only thing you've missed really is if someone says, well, what sort of telescope should I get? The best telescope is the one that you can get out easily and use, rather than spending half an hour setting the damn thing up. That's for real enthusiasts, but for a casual person, something you can bring out the cupboard, put on the ground, have a look through it. That's the best one.
I think if you've got somewhere, you know, if you've got to get in the car and travel somewhere because there's nowhere suitable where you live, that would imply that you need something smaller rather than larger. Because you're transporting it and it gets more and more difficult.
I know.
What's the best camera to use? It's the one that's convenient to use, and if that happens to be your phone, that's the best camera that you've got.
I know I'm flogging a dead horse saying it, but I mean, some people get, as we know, some people get telescopes given as gifts at Christmas or whatever. But I can't understand, and I know one or two people I won't name who bought telescopes. They've taken no advice at all. They've just gone to the shop, thought, oh, like the look of that one, I'll buy it. And I'm thinking, well, surely you'd take some advice first before you, you know, you had an outlay of, I don't know, £200, £300 or whatever it is you're paying. You would ask somebody first, but I've known 2 or 3 people who've just got the telescope without any reason why particularly, except they've liked the look of this one and they bought it.
I think one of the cons is go and get a telescope. Yeah, it's going to cost you 350 quid. Oh, but then so you'll need this light tank to do the electronics, and you need this and you'll need that, and you walk out of the shop and you spent 700 quid, not 350.
Interesting on these, the club we had on loan for some time a fairly ordinary cheap telescope, which was actually an equatorial one, and the person who'd used it before we borrowed it didn't understand that and had actually set it up and shoved everything round so it just behaved like an azimuth, which I thought was most peculiar. It's gone now. It went back to who it belonged to.
One of the pieces of advice that I give people is once you've got your scope set up, don't let anybody fiddle with it. The very first time I came on an Astro's visit, there was an old chap there, and he came over, and I thought, "What the hell are you doing?" I said, "What are you doing?" He said, "I'm just adjusting it for you," and he undone all the adjustments for the primary mirror. It took me I had to go back to the place in Batley to get it realigned because he just totally unhinged the primary mirror.
Say thank you to him.
If it had been seen a little bit earlier, I kicked him in the shins.
Well, no, I think that's human psychology, Bill, because when I was teaching a U3A class, and I remember this guy, and he was an old guy, so I thought, you know, I should treat him with reverence. And sometimes I'd have to just pay a quick visit to the toilet, and I'd come back, and he was fiddling through my papers and books. Oh, this is what we're going to do today. And I thought, take your bloody hands off. It's nothing to do with you. My papers are my papers. My books are my books. And the idea of somebody going and looking through, you know what I mean? It's like, sorry, as a doctor, somebody going and picking up the x-ray and saying, oh, is this me then? And you think, no, hang on. Don't interfere with somebody else's equipment or somebody else's property, you know.
Okay.
The doctor in me saying shirt buttons or zip on the fly.
Just so I have the time ticking by again.
Yeah.
Does anyone have any last question or point to raise?
Just one very simple observation, and that is that I am amazed at how quickly Orion has disappeared. It was there, and it's gone.
Oh, sorry. You mean tonight?
Well, I mean,
I saw it last night.
Yeah, but it's not there as it used to be. It's sort of done that.
It's at its best at about 8 o'clock at night now. So you've got the rest of the winter time, GMT, to see it. It's progressively earlier and earlier, but I mean, it's properly dark nowadays by what do you suggest, about 6:30? So you've not got too long to see it at its best when it goes through south. I was looking at Alnitak last night, and I had the same problem. It was starting to go down by the time I got everything ready. I'm aware of the time again.
Say, Rod, you do get my favourite constellation, Leo the Lion, in the south, and it looks quite magnificent, really does.
Give it another few months and it'll be south at a decent time in the evening. So looking at all your galaxies then. I'm aware of the time. I think we better stop because it's after 9:30. We were thinking, or one or two of us, possibly looking at astrophotography, just very basic things, next time when we have one of these question and answer sessions. Hopefully not from me, be from someone else, and that hopefully will lead into a discussion about that. But in the meanwhile, if you do still have problems and questions that you've always wanted an answer to, then do use the chat line and we'll see what we can do. And the best opportunity, of course, is to come to the New Inn when sometime in the distant future we really will get a clear night and we can have a proper observing session. You can bring all your equipment then and we can go through it all with you. Okay.